Welcome back to part 2 of lesson 2.4, and as promised we are now going to do an example that I wrote out in your paper. So I'd like you to copy that, put that there. Looks like I need to trim that a little bit, which I will do in a minute. But I want you to tape that in. And we're going to jump to part 3 where it says use Descartes' rule to determine the type of zeros. I want to do that first. So I'm first going to do part 3. And I'm going to look at the use Descartes' rule. I'm going to look at the function itself. Well, the function itself is just 2x cubed minus 5x squared minus 11x plus 14. And if I just look at that function, it went from positive to negative. There's one change. Negative to negative, negative to positive. So it has 2 or, subtract 2 from 2, 0 positive zeros. Okay. Now I'm going to evaluate it at the negative x function. So I need to evaluate here, everywhere there's an x, I'm going to evaluate it at negative x. Minus 5 negative x squared minus 11 at negative x plus 14. Now when I evaluate this, I need to simplify this first before I can count the negatives. If I have negative x times negative x times negative x, 3 of them, I'm going to have a negative x cubed. So that's going to change the sign to negative 2x cubed. Negative x squared is going to be a positive x squared times a negative 5 is still minus 5x squared. This is negative x times negative 11. Well, that's going to give me a positive 11x. This right here will give me a positive 14. That doesn't change at all. So let's look at the times it changes. Negative, negative, positive. There's one change. So I have 1, negative, 0. If I take 1 minus 2, I'm at negative 1. I don't want to go less than 0. So I just have 1, negative 0, period. That's very good to know. If I was doing all those zeros by myself without the calculator and I had to do all the synthetic division, once I found a negative 0 that worked, I could stop testing the negative ones. Okay? Let's go back and do some more of this criteria. I'd like to find the upper and the lower bound. So now we're doing part 1. And first, remember, we graph it. And then we're going to try a boundary. So I'm going to pause it right now so I can type this in. There we go. So I've got it in the calculator. Let's graph it. Okay, it crosses 3 times. Remember, you have at most 3 zeros because it's to the 3rd degree. And it looks like it crosses there at negative 2, which means I'm going to try my lower bound to be negative 3. 1, 2, 3, 4. I'm going to try 4 as my upper bound. All right, so we're going to try negative 3 and 4. Now again, if I didn't have a calculator to put that in there and kind of get the answers and get an idea of the zeros to begin with, then I would have to just try different numbers and do the synthetic division and see if I get the alternating sign or all positive, and then I would know that was an upper or lower bound. So remember, if we try the lower bound, we're going to do synthetic division with negative 3. My coefficients are 2, negative 5, negative 11, and 14. I'm going to do the synthetic division, drop the 2, multiply, I get negative 6. Add, I get negative 11. Multiply, I get a positive 33. Add, I get a positive 22. Multiply, I get negative 66. Add, I get negative 52. I don't care what the remainder is. I don't care specifically what the numbers are. I'm only looking at the signs. Positive, negative, positive, negative. So, yes, they alternate. So, -3 is the lower bound. All right, now let's try 4 as my upper bound. Again, same coefficients. To multiply 8, add 3, multiply 12, add 1, multiply 4, add 18. All positive, all non-negative. Whoops. So 4 is the upper bound. I'm running out of room there. So we have the upper and lower bound, and that would be just one of my questions. Determine an upper and lower bound for this function, and you would need to verify and prove it. You would graph it, you would try it, you would show me the synthetic division and show me that the signs alternate. Okay? Our problem up here said list all possible zeros. Remember, that is dealing with the rational zero theorem, and we've got to do the P's and the Q's there. So let's go. This is part 2 of our problem. And we want to list factors of, okay, so this number at the top, the numerator, where's my function? Here it is. Is that going to be factors of 14 or factors of 2 in the numerator? And it always is the 14. So I have factors of 14 divided by factors of the leading coefficient, which is 2. So here we go. I have 1, I have 2, I have 7, I have 14. Those are all the factors of 14. Factors of 2, this is very similar to the other one we did, and 2. So when I list all the possible zeros, I'm listing the P's over the Q's. I'm making all these rational fractions. But the first ones are just going to be, remember, over 1. So if I just list those numerators and put them all over 1, I have those numerators. I haven't changed anything. So that's 1, 2, 7, 14. Now we're going to list them over 2. So I'm going to have 1 over 2, which is obviously a half. I'm going to have 2 over 2, which is 1, and I already have 1. 7 over 2, I do not have that one yet. Positive or negative 7 halves. 14 over 2, I already have, that's 7. So that is the list of all possible rational zeros. Now, we already know from part 1 that they are between the interval of -3 and 4. So because they are between -3 and 4, which was part 1, okay, I can come up here and I can get rid of -7 and +7. They are not within the interval. My zeros would not be there. The 14, -14 and +14 are too big. That's a huge help. That just saved me from doing 4 synthetic division problems. Right? So that's really helpful to have the upper and lower bounds. All right? Now let's go, and part 4 says to verify the rational zeros with synthetic division. Oh, you can't see it. There it is. Verify rational zeros with synthetic division. Well, do you remember when we put it in the graph to check the upper and lower bounds? So for part 4, from the graph, we're going to try -2. Do you remember? Let me see if I can pull it up on the calculator. See how I have -2, and we already know that there's only one negative zero. So I don't need to worry about having any more negative zeros. And it looks like it crosses here at 1, but there's going to be a fraction. Well, I have a fraction. I have 1/2 and I have 7/2. Well, 1/2, it's way past that. Well, a little bit past that because I think it's at 1. But the 7/2, all right, that could work. That would be 3.5. So I'm going to try those values, 1 and 7/2. We're going to see if those work with synthetic division. So here we go. We're going to try -2. Remember, pull the coefficients off. They're 2, -5, -11, 14. Drop the 2. Multiply, -4. Add, -9. Multiply, +18. Add, +7. Multiply, -14. Yay! Look at there. We got 0. That 0 indicates that the -2 worked, and x does equal -2 is a 0. Now, if I want to try the -1, I'm going to just keep working with this answer. I've broken it down. I basically factored it already by the x plus 2, and so I'm going to use these coefficients first to do it with the 1. So I just draw another box here, draw another line, drop the 2 down again, play it again. 2 times 1 is 2, add -7. Multiply, -7. Oh, will you look at there, you got 0 again. So that means that that one worked and that x equals 1. Now remember, when we did our original function, it was to the cubed. It was a degree 3. So that meant this was the 3rd degree, this is the 2nd degree. This answer is just x. Well, I'm just going to go ahead and write that. That's 2x minus 7. Well, look at there. What does that give you? That tells you that x equals a positive 7/2. And we got out of doing synthetic division with a fraction, which is always nice. So let's list our factors. You already have the zeros, but the factors then would be this one that we have 2x minus 7. If the 0 is 1, you know the factor is x minus 1. If the 0 is -2, you know the factor is x plus 2. And those would be the factors. Now what we just did when we went back and forth is something that I would like you to be able to do with complex roots as well. So we're going to set this up, and I would like you to do most of this on your own, and then we'll check it in class. But I'm going to help you set it up first. So when you are dealing with complex roots, you need to remember that the square root, or I squared, is equal to -1. And the square root of -1 is just I. And I don't know why I made this Roman numeral 3. It's really just 2. This is the second part we've done. So if you have a problem, you're now going the reverse. If I say the zeros are -3, 1 with a multiplicity of 2, and 4i, I want you to write those factors out, multiply them, and give me the polynomial. You're going backwards. So let's list the factors. The factors would be, I'm going to have this x here of x plus 3, right? I'm going to have another factor of -1. The 0 is 1, so my factor would be x minus 1. But I have a multiplicity of 2, so I have 2 of those. Now I have another 0 of 4i. That means I have x minus 4i to give me positive 4i. Now, this is the kicker. This is what a lot of people forget. When you get plus or minus, when you get imaginary numbers, think of when you do the quadratic formula. and you're getting plus or minus a square root. You have to account for the opposite. So you have to account for x plus 4i. It is going to be assumed that you know that. That is very important. And if you notice, it wasn't listed here. It just listed the 4i. They're going to assume that you know that you also need to include that. So what I would like you to do is to multiply this out, and let's see if we get the same answer. I will tell you that I usually start multiplying those, and I multiply these. Make my eyes go away initially. I'm going to get those two, that product, this product, and then I still have to multiply by the x plus 3. So I would like you to work this out, and when you come to class, we will check it and see if we all get the same product. Practice. It's not that hard, but you do need to distribute quite a bit when you're multiplying, because on one point you've got a 4-term polynomial times a binomial. Okay? I will see you in class. Thank you. And we'll do the classwork for 2-4 together. Thank you.